So, I did some stuff regarding procedural generation as well as saving and loading. As you see here, this populates an area um, with a random position of a certain number of objects. It uses this one, which shows a placeholder object, because this you can just change this to another model and it will change it to chairs. Go back to bushes, and it has two variables, and both of them are instance editable. And this allows anyone using this to simply drag this into the scene and set it to however many they want. So let's say you want 15 bushes, and you want it in a really small area. You can just set it in there, and you don't have to go into this. And it does this with, it takes the number of bushes you want, and it goes for each instance. You will add a mesh at a random position. And since you don't want it going in the up, and you only want the X and Y, just break it and make it without the Z. And that allows you to do a random of those. For saving and loading, I have it set so the tutorial itself only gave saving, and it used the first person character to do it. Instead, I changed it to event dispatchers. 1K is saving, L is loading, and then it uses my save game in order to save the variables I want to save. In this case, I only went with player transform to keep things simple. And my save game is, it has the parent class of save game. And then this is a version of save game just named my save game. And then through the level blueprint, I have it so it'll cast a person character. This allows it to use the event dispatcher of K or L, does saving or loading. And then here are the actual movements. So the K is hit, then it will do save game. If L is hit, then it will do the load game. And the loading has branch, but this is only because the first time you hit the button, the first time you save, no save game exists for this name. Which you can have as an array, but in this case I only need one, so I just named it slot name. This asks, does a save exist? Because if a save does not exist, then it will need to create a save game object. And you're going to want to create the save game under the one where you have your variables. You will then save that, and it will cast to save game. And casting to it allows you to use the variable from this. So you can see it's not here. This is this variable. Casting to it allows you to use that. And you save the game to the slot, and this just lets anyone looking at this know that I've hit the button and it's gone through. And if a save game already exists, it's exactly the same. The difference is that it will load a game instead of creating a save game object. And then I added the loading game data. It asks, does a game exist? And if it doesn't, then it just doesn't load anything because there's nothing to load. But if a game does exist, then it will load that game, and it will cast to it, and it will get whatever was last saved. And then it will set the actor to that number that was saved. Well, in this case, transform that was saved. And then I have it printing the stream saying that it is loaded. And the way that works in practice, it's going to be loud, apologies. Okay. So, I'll save over there. And I'm doing this because I want to point out that it only saves what you tell it to save. For example, I only save the player transform. So when I load, it only does the player transform. Nothing else was saved along with it, so it won't reset any of that. You'd have to tell it to, or perhaps there's another method I haven't learned about that'll allow you to do that more. With more options or But either way, this allows you to, in this case, save the position of the player character and load the position where you saved the player character at. And then one more, which is a map. Okay. For the other procedural piece is level streaming. So whenever I hit play and simulate it, it will populate, in this case, a 10 by 10 world that is randomly generated based on the tiles from here. So I have 3 different types that can be spawned in. So blank one, this one has a small student, so this one is stat, and it will populate this randomly. And it does this through the level blueprint. So at event begin play, it has 2 loops. One loop is for rows, the other is for columns. This decides how many it is. So, but that was 10 by 10, so you can make it, I don't know, 5 by 5 or such. And you can make it 2 variables if you want to do the row and columns at a different length. You also have tile size. In this case, it's 1,000 because that's just how big that one is. And then it goes through this math to make a transform. And the transform decides, like, for example, this block is here, but the next block needs to be over here, and then over here, and then over here. And that's how it gets the placement for that transform. And when you do this, you can just right-click this and split the struct bin, and that allows you to get that. And it goes through the loop for each square, each row, and each column. It goes through, and it will create an instance of one of these, and it chooses which one by using the random integer, the max of the length, and a list of each one. These names need to be exactly what they are up there for it to pick one of them. And then it creates it, and it decides where to create it by setting the level transform, using that, and it also should be loaded and should be visible. And then it also gives a unique instance name for each instance using the index of the row, then an X, and then the index for the column. And that is what allows this to populate, in this case a 10 by 10 world of 3 different level pieces, and it's different every time you open it. Right, that's all for that.